Hello friends, welcome back. This is a second lecture in a series related to the direct influence in aromatic electrophilic substitution. We all know that the learning objectives of this particular video lectures, the partial objectives were fulfilled in the earlier lecture, in which we have tried to cover the effect of substituent on reactivity and directive influence. We have also covered the activating and deactivating groups and orthopara and meta-directing groups. Now, in this particular video lecture series, in this particular lecture, we will cover the directive influence of these four groups which will be a part of your curriculum. So we'll see how this methyl group directs the incoming electrophile, how OH group and how Cl group and NO2 group also directs the incoming electrophile to the various positions in the benzene ring. This is what we will try to cover in today's talk. Moving ahead, first of all, we will develop a generalized approach. So we all know that the effect of substituent present on the benzene ring on its reactivity and the direct influence of the substituent can be explained on the basis of inductive resonance and hyperconjugation. The word hyperconjugation is missing here. So these three effects will be useful, and we all know that electron displacement effect can take place. Electron displacement means withdrawal or the release of electron can take place through a sigma bond through sigma bonds in inductive effect and pi bonds in resonance effect. So if the group or atom attached to the benzene ring releases electron into the ring either by plus I or plus R effect, or if the group or atom attached to the benzene ring withdraws electron from the ring, then it is minus I or minus R effect. So based on these fundamentals, we'll move ahead and we will see how we can explain the direct influence of the different group. Now, the direct influence of the CH3 group we will see first. We have to see the direct influence of the four different groups. The first of all, we will see the CH3 group. So you have to keep this picture in your mind that CH3 group is a carbon bonded to three other carbon and bonded to the aromatic ring through this bond. Now, looking at this particular structure of the group, you know that there is no lone pair of electron in it. What it has is only a sigma bond. So when a sigma bonds are only present, then the possibility of inductive effect and hyperconjugation is to be kept in mind. So the explanation for this particular topic will start like you have to start with an affirmation that CH3 group, like all other alkyl group, is activating and orthoparadirecting group. Now we have to prove that CH3 group is activating and orthoparadirecting. And as I mentioned that there are no pi bonds and lone pair, so there is no question of resonance. So you can explain it on the basis of inductive effect and hyperconjugation. So what happens? First of all, we will explain it on the basis of inductive effect. So looking at the structure of benzene ring, looking at the structure of methyl group, which is bonded to a benzene ring. So as in case of toluene, this carbon is having the electronegativity of 2.4 on Pauling scale, and hydrogen is having the electronegativity of 2.1 on the Pauling scale. So naturally there will be an electron pull from hydrogen to carbon. So this carbon will attract electron from all the three hydrogens, and as a result this carbon will become electron rich, and electron rich carbon will give its electron density to the benzene ring. So the overall thing is this methyl group will exhibit a electron donating inductive effect. Electron donating inductive effect is denoted by convention it is referred as plus I effect. Okay, so CH3 group is electron donating by virtue of plus I effect, number one. Number two is there is a possibility of a hyperconjugation. You know, hyperconjugation involves the overlapping of a pi bond with the adjacent alpha CH bond. So this is alpha CH bond in the context of the pi bond. Now how it happens, we'll see it in the next slide. So CH3 group donates electron by means of hyperconjugation. Hyperconjugation is also called as no bond resonance or sigma bond resonance. How it happens? Say this sigma bond comes in and this pi bond open up this side. So what will happen? This will be left H plus. It will be in the closer vicinity. It will not leave. It will not go far from this benzene framework. It will be in the closer vicinity of this, and there will be a negative charge. and you know that negative charge and you have alternate single bond and the double bond, so there is always a possibility of delocalization by resonance mechanism. So what will happen, this negative charge will move here, positive and negative will generate a double bond, so this new fresh double bond will be formed. And in the third step, what will happen, this bond will open up this side and there will be a positive charge here, positive negative will generate a double bond here. So as a result, what will happen, the negative charge will be delocalized over the ring. So what has happened, I have shown only one hydrogen, so there are three hydrogens, so you can repeatedly draw the considering, I have considered this hydrogen, you can consider this hydrogen and again draw three hyperconjugative structures, you can consider this hydrogen and again draw three hyperconjugative structures. So what is happening is through hyperconjugation, the sigma bond of the carbon hydrogen sigma bond is getting interacting with the pi bond of the benzene ring, and there is occurring a shift of electron from the methyl group. Because if I draw a line from here, say I draw a line from here and say this is your group, methyl group above the red line and your benzene ring below the red line, what you can notice from this is, you can notice that in the first structure there is no charge above and below the ring, but in the subsequent structure there is a negative charge on the benzene ring and positive charge on the methyl fragment, which means that there is a shift of electron from the methyl group to the benzene ring. So what you have to do while preparing your notes, you have to draw the structures, resonant hyperconjugative structures correctly, and just observe the hyperconjugative structures and write in terms of sentences. Like what will happen, so from the resonating structure it can be seen that electron density on the benzene ring increases at ortho and para position. You see a negative charge at ortho, two ortho positions, and a para positions. There is no charge at the meta position, isn't it? So what will happen, the CH3 group is giving its electron density to the benzene ring, number one, and number two, it is increasing the electron density at ortho and para position. So where will the incoming electrophile will go? If the incoming electrophile is, say you have an E plus electrophile, incoming electrophile E plus here, where it will go? It will prefer to go to the either to the ortho or to the para. It will not go to the meta position. So this clearly proves that CH3 group is ring activating and ortho-para directing group. Now we'll see the direct influence of the OH group in the light of modern electronic theory. Modern electronic theory means here you are trying to explain it on the basis of electron displacement effect. Okay. So what is OH? OH is activating and ortho-para directing group. Now have a look at the structure of the OH group. The oxygen which is bonded to the benzene ring has got couple of lone pairs and is bonded to the hydrogen by sigma bond. So here this lone pair can come into interact with the pi bond and come into a resonance with the pi electrons of the benzene ring. So and at times oxygen is bonded to the carbon, so there is the difference of electronegativity, so there will be an inductive effect that will also come into play. So we'll try, so there will be no hyperconjugation because there is no alpha CH bond. So you can explain the directive influence of the OH group on the basis of inductive effect and resonance. So what will happen? First of all, we'll deal with the inductive effect. Oxygen being more electronegative than carbon, the electronegativity of oxygen is 3.4 on Pauling scale, that of carbon is 2.4, which means that there will be an electron pull from the carbon of the benzene ring to the oxygen. So what is the overall effect of the group OH? The OH will exhibit an electron withdrawing inductive effect, which by convention is referred as minus I effect. So OH by means of inductive effect will be a deactivating group because it is taking electron density away from the benzene ring. So OH will exhibit minus I effect. But the story is not complete yet. We have to see the second part. What is that? Because there is one more effect that will come into play. What is that? Resonance. So in the next slide, we'll see how the resonance will come into play. So this lone pair will come down here and this double bond will open up this side. So what will happen? What will happen? There will be a negative charge at the ortho position and oxygen will be a positive charge. Again, I will draw a line which will divide the substituent from the benzene ring. So this particular line in the structure number 1, you can see that there is no charge on the upper part as well as lower part. But because of the resonance, because of the shifting of the lone pair of the electron, what is happening? The oxygen is getting positively charged in all the three structures, subsequent three structures, and a negative charge on the benzene at ortho and para position, which means that there is an electron pull from OH to the benzene ring. So electrons are moving from the substituent to the benzene ring. What is this effect? This is electron donating resonance effect. Electron donating effect is by convention it is referred as plus R effect. So from these resonating structures, it can be seen that the electron density on the benzene ring increases at ortho and para position. Thus, incoming electrophile will be directed to the ortho para position, not at the meta position, because meta position remains unaffected. So what is happening? There are two effects operating. One of them is electron withdrawing, other one is electron donating. However, means there is one minus effect. So minus I, and the second effect is plus R, and the overall effect is what? The magnitude of plus R effect is higher than minus I effect. So overall effect is what? Plus. Plus means electron donating. So the so what will happen? The OH will be, by and large, the OH will be a ring activating and orthopara directing group. It is a weakly reactivating because the electron density which is given by plus R effect is being taken away by minus I effect. But the magnitude of plus R is more than that of minus I, and that is why overall effect is a electron donating effect. That is why OH is weakly ring activating and orthopara directing group. Now we'll see the third group, which is NH2 group. Now NH2 group is also a ring activating and orthopara directing group. It can be explained very similar to the OH, because the NH2 group is an nitrogen analog of OH, where you have one lone pair on the nitrogen and two hydrogens bonded to the nitrogen by sigma bond. So again, there is no question of hyperconjugation. So there will be two effects that will come into play, that are inductive effect and the resonance effect. So what kind of inductive effect it will exert? Nitrogen being more electronegative than carbon, having the electronegativity of 3.04 on Pauling scale. So there will be an electron pull from carbon to nitrogen. So the overall effect of the NH2 group will be, sorry, I missed one of the hydrogen to be drawn here, because there should be one more hydrogen here. I should draw it right now. Just a minute. I have to draw one more hydrogen here because I skipped it. So you can draw a hydrogen, one more hydrogen here, right? So this NH2 group, as such, what it will do? It will exhibit a electron withdrawing inductive effect, that is minus I effect. At the same time, very similar to the OH group, the NH2 group donates its electron by means of resonance. These are the resonating structures. Again, have a look at these resonating structures, and you will notice that the lone pair of electron on the nitrogen is being given to the benzene ring and shifting the pi bond to the ortho position. So what is happening? The overall effect is these structures are very similar to the one we have seen in case of OH. Again, I will draw a central line separating the group from the benzene ring. What has happened? In the first structure, there is no charge on the group and no charge on the benzene ring. But in the subsequent structure, there is a positive charge on the group and negative charge on the benzene ring, which means that there is an electron flow from the group to the benzene ring. So what is this effect? This is plus R effect. And looking at the specifically at the separating the ortho and para positions, you will notice that the negative charge is increased only at the two ortho and the para position. So what will happen? Again, the two effects will come into play. What are those two effects? Minus I effect of NH2 group and plus R effect. Again, the magnitude of plus R effect is greater than that of minus I effect. So overall effect makes it an electron donating group, or makes it an ring activating group. Thus NH2 group is a ring activating and ortho para directing group. We'll see one more group, and that is the directive influence of the Cl group in the light of modern electronic theory. Cl is activating and Cl is deactivating and ortho para directing group. Again, have a look at the structure of the group. So halogen, chlorine having 3 lone pair and a single bond. So chlorine exert a strong electron withdrawing inductive effect, because electronegativity of chlorine is 3.16 and that of carbon is 2.4. So Cl will exhibit a strong minus I effect on the benzene ring. So by virtue of inductive effect, Cl will exhibit a minus I effect and will withdraw electron density from the benzene ring. On the contrary, if you consider the resonance, you will notice that the lone pair of electron on the chlorine gets onto the benzene ring via resonance mechanism, giving, again I will do the same thing. I will divide the group substituent and the benzene ring by a line, and from these you can notice that there is a positive charge on the chlorine and a negative charge on the benzene ring. So you can clearly notice that there is an electron flow from the chlorine to the benzene ring. So from this one can easily conclude that, and where is this electron density increase? Especially at the 2 ortho and the para position. There is no change at the meta position. You can see the meta position in all the 4 structures. So there will be 2 effects operating here. One of them is minus I and second one is plus R. But in case of chlorine, what has happened? The minus I effect is having the magnitude of minus I effect is greater than that of plus R effect. Means minus of my effect predominates over the plus R effect. So making the chlorine as a deactivating group. However, the ortho and para positions are more electron rich as compared to the meta position. So the incoming electrophile will be directed to the ortho para position. So that is why Cl is a deactivating but an ortho para directing group. Now the last functional group that we have to see as per our syllabus, which is NO2 group. Now NO2 group, the central nitrogen atom which is attached to the benzene ring do not have any lone pair on it. So this nitrogen, this is again an heteroatomic group. So again there will be 2 effects that will come into play. What are those? Inductive effect and the resonance effect. So NO2 exerts a strong electron withdrawing inductive effect, which is minus I effect, and decreases the electron density. Have a look at the electronegativity. Oxygen 3.44, nitrogen 3.16 and carbon 2.4. So nitrogen, electron density on the nitrogen is taken away by the oxygen, making this nitrogen much more electron deficient, which in turn will pull the electron from the benzene ring. So minus I effect will be very strong, that will be exhibited by the NO2 group. Now the second aspect is resonance. If you try to draw the resonating structures, you will notice that this pi bond will open up. You see this is a very good condition for resonance. You have a double bond. There should be there is one typos here. What is that? There should be a nitrogen here. I forgot to draw the nitrogen in all these structures. So I will draw a nitrogen over here. So in all these structures you could see that there is an electron pull from benzene ring to the nitro group. So this, looking at this nitro group, you can see a reverse case what we have seen in case of OHCl and NH2. What has happened? There is a positive charge on the benzene ring. Earlier there was no charge, and there is a negative charge on the NO2 group as such. So it means that there is an electron pull from benzene to the NO2 group. So this group in particular exhibit, this is not plus R effect, it is minus R effect. So it will exhibit minus R effect. So what will happen because of this? There are 2 effects operating in tandem. What are those effects? Minus I and minus R effect. Both these effects will take away electron. And now have a look at the resonating structures, and you will notice that there is a positive charge at the ortho and the para positions. So ortho and para positions are positively charged, whereas your ortho and para positions are positively charged, whereas meta position is unaffected. So whenever the incoming electrophile is placed in this particular system, it will prefer to go to the meta position, which is relatively more electron rich as compared to the ortho and para positions which have got the positive charge. So the overall effect is, both the effects minus I and minus R effect will make this NO2 group as a ring deactivating group and will direct the incoming electrophile to the meta position. So these are 4-5 different groups whose directive influence we have tried to study in the light of modern electronic theory. Thank you. Prepare your MCQs and notes based on this. Thank you.